Hey everybody, how are we doing? Got started a little bit late here today. Sorry about that. Had to do some errands this morning. And yeah, got anyone in the chat? Let's see if anyone has found the video yet. Oh my gosh. Put on a little chill music right here while we get started and figure out how to put on headphones. Hey Brian, what's up? Do you want to do some of the work of the week? Should we do some of the work of the week? I'm gonna post about it. I bet someone said, "Where are you?" And I'd be like, I had to run out this morning. General chat. Yep. Just started here. There we go. There's that. Canvas quizzes. Which Canvas quiz are you wondering about? Which Canvas quiz are you wondering about? Let's see. Good afternoon. Brian, do you want to do a little 320 to start? We can start up here with some 320. And Angie, good to see you too. Ask those questions in the chat. This is your time. We got about right under an hour to do some work here. What should we do? Yes, please. Okay, let's start talking about this week's assignment. Okay, let's head over to here. Let's do it. EAS 320 upcoming assignment. So 203. BS 320 correlation assignment. Okay, so this week is over correlation. And actually, I got core demo up. And really, what's good is for 201, we're doing correlation also. So when you do correlation, oh, look at this. Might not do it properly. We got to fix it right here. We're going to hit end on this. And I got to hit end. There we go. Let's go here to view. Actual size. There we go. Correlation is usually used for linear correlation. So you see how this is a correlation of 1. Let's redo it again right here. This is a correlation of -1 as best as I can draw. There's the -1 up there. You can add outliers, and we know outliers can do anything to correlation. Go over last week's assignment. We might need to meet over that. But since that one's not due, I might just do... Brian, let me know. We could probably meet on Discord over it. Going over last week's assignment, we can review those topics. This is going to be really helpful for this week here and getting the work done. So I think this might be the best right here. Let me see. This is Denver, Colorado. I'm going to answer this really quick right here. Really quick. Be right back. Okay, we are back. Sorry about that. This week's data analytics assignment. We're supposed to do it on Excel or Jump. Yes. Here, I'll show that next doc. You got it. We'll show that here next. This week's visualization assignment. You got it. So we're talking about correlation right now, which is covered in all classes. What can outliers do to correlation? So who knows in the chat right now for points? What can outliers, like if you have a weak correlation down here that is close to 0, see that's a correlation close to 0 because it looks like a 0. What could outliers do to this correlation? Body temperature. Let's do that next. So that's the Canvas content, right, Angie? I'll write that in the notes. Canvas content next. Well, not really skew it. Canvas content. A good answer right there. And then we've got data analytics. So the idea of skew is used for univariate data. So a histogram is said to be skewed to the right. So this is a right skewed histogram. This is a symmetric histogram. So the idea of skew deals with univariate quantitative data. In Stat 201, we talk about shape, center, spread, and the idea of skew. And Brian, good answers right there. We got 3 points for those answers. So the idea of skew is used for histograms to say it's skewed to the right, it's skewed to the left. But when we talk about correlation ranges between what and what values. And this is what we'll be covering tomorrow. And 201's also covering it. So if you're in 201, this applies to you. So correlation can be as low as what? Or correlation can be as high as what? Remember, this applies to 201 and 320. You should know the range of values for correlation. So correlation goes between what and what? What are the range? Between -1 and 1. Good answers, Brian. So -1 and 1. We're throwing points there. -1 is perfect negative, and you see the negative, that's -0.99. It's not perfect on a line. It looks like that point didn't follow a line perfectly. And so positive is perfect upward, which shows the direction. You see I'm not perfectly on the line. The closer we get to the linear, it might actually round up to 1. See, now it's not perfectly linear positive. Now, the weakest correlation is a correlation of 0, where it looks kind of like a blob. But you have to be careful. Hey, Nick, good to see you here. Because you can actually have correlations like this, where what is the correlation for a parabola? What is the correlation for a parabola? This applies to 201 and 320 right now. So you can see the value of correlation right there, which is R. The correlation of a parabola is close to what? The correlation of a parabola is very, very close to what? What is the correlation of a parabola? 0, Doc, great answer. And YH only measures what kind of relationships? This does have an association, which is a question we put on the test. Correlation only measures what kind of relationships? Correlation only measures, specifically Pearson's correlation. Pearson correlation only measures what kind of relationships? Pearson correlation only measures what kind of relationships? Linear, that's correct. That's the reason we have the conditions. QQ straight enough, no outliers, because the straight enough would say this is not straight enough for correlation to be applied to it. So is there a relationship in this graphic right here? Is there some sort of relationship in this graphic? Answer yes or no. These, although we're doing coding right here, these are all concepts on the 201 test and 320 test. Is there a relationship? The answer is yes. But why is correlation 0? The answer is yes, there is a relationship. It's parabolic, but correlation right here, R, is 0 because correlation only measures the strength of linear relationships. So there's not a linear relationship, there's a parabolic relationship, and it's actually very strong. So you can have a strong relationship that doesn't have a linear component to it. So very importantly, we're going to need ways to analyze and look at data. So let's do this right here. So we're going to end this graphic right here. And let's take a look at a little bit of data and then do some 201. See, there's the correlation of basically 0 with a non-linear association. So I am using the MT-Cars data frame. This is a data frame with a bunch of car data. So if you're a car fan, you might understand things like miles per gallon, cylinders. I don't know what disp is. I think it's a ratio of something. Horsepower, drat. This is V-shaped versus inline or something. We won't use those because those are kind of indicator variables. I'm not going to talk about those quite yet, but let's see if the horsepower of a car is related to the weight of a car. So we're going to use, and this is what you'll be doing this week, library, reg class. And with reg class now turned on, we can go to associate, and we're going to go and see if the miles per gallon can be explained by the weight of a car. And I totally forgot to do data equals, we'll do that on a new line, data equals MT-Cars data frame. And so take a look right here. This is the plot. Now, why do you get 2 histograms? Does anyone know why you have 2 histograms for 50 points right here? A scatter plot is the bivariate visualization of 2 quantitative variables. These are called border histograms because it's a histogram of what? So look at the labels and think why there's 2 histograms here. Like you'd say, well, you can't make a histogram with 2 quantitative variables. And I'd say, but this is a histogram of only. People see it, this is a histogram. Well, so the scatter plot, good answers, Megan, right there. The scatter plot is bivariate because this is the relationship weight and miles per gallon have, which is a negative relationship. There's a little bit of nonlinearity. And miles per gallon right here is shown as a histogram of only miles per gallon. So this is just one variable histogram, one variable histogram, and those are called border histograms. So each histogram is showing one of the quantitative variables. We won't talk about the permutations down here. Let's focus on the values of correlation. So notice the value of correlation is negative, but there's Pearson correlation. And which one of these do you think we use in 201? Because there's a hint right here with the notation. In 201, you only learn about what? In 201, you only learn about what correlation? Think about the website you go to. So this is where we'll talk for 201 and 320. We're going to do some more 201 after this. You only learn about Pearson's correlation. So Pearson's correlation is the linear one, but there is Spearman rank correlation. Now, it sounds more complicated than it is. The way Spearman's rank correlation works is if you have data, and actually we can plot it. Here, I'll draw you what the data is going to look like. It's going to look something like this right here. Does this have a linear relationship, yes or no? Is there a linear relationship in this data? Like is that a good linear relationship? Does a line fit well through this data? That's what I'm asking. Does a line go through this data well? Can I make a line go through that data well? Not really. No, I agree with you, Brian. And good answers, everyone. Not really. There is a linear component, but it's got some sort of, if I were to really draw this relationship, it would look like that, right? It's more exponential. So there's more of an exponential relationship. So the way Spearman correlation works, so 201, you don't have to learn this one, is let's say we have the values right here on X and Y. This is the lowest X, this is the second lowest X, this is the third lowest X, this is the fourth lowest X, and this is the fifth. We got to make sure that point is to the right of it. Does that make sense? I'm just going by order they occur. And then if we talk about the Y values, this is the lowest Y, this is the second lowest Y, the third lowest Y, the fourth, and the fifth. Now take a look at this. Notice that the ranks increase with each other. And this is why it's called Spearman rank correlation, because you're not correlating the actual values. These values could range from 0 to 100, but you're only correlating the ranks. Isn't that the same with linear? Well, so when we do this, we would actually, if you look at what we're doing for a correlation right here, we'd make a correlation plot of the ranks, or that's what's being mathematically calculated. And so this would be a correlation for Spearman when we take this down here, and we don't actually make this plot, but if you did, it would be equal to 1, because there's a perfect Spearman rank correlation. Does that make sense, Brian? So Spearman doesn't use the actual values. So here's the actual values on the bottom, going from 0 to 100. Spearman uses the ranks of the values. And what is a big reason to use Spearman rank correlation? What is a big reason? And let me show you another data set. What is a big reason to use Spearman rank correlation? A huge reason to use it is when the association is what? This is key to this week, which you'll need to explain as you go through data. A big reason to use it would probably be something like this, when what? And then we're going to make one more graph and we're going to do 201, nonlinear. Also, think about this. If there are 699 points in this data set and we give things ranks, well, then the ranks would range from what to what? If there's 699 points, then the ranks would range from what to what? So if there's 699 points, on the x-axis, we'd have the lowest x, and then we'd have the highest x. They'd range from 1. Great job, Megan, right there, and Brian. Yes, that's correct. So think about this. What if we have a value right here? Our x values are something like 1, 2, 3, and a million. So if that's a million right there, there's a million. What would be the ranks of those? And you'll see another characteristic of what Spearman does. What are the ranks? Ranks of x. And we can make it trickier by putting a million here. So there you go. So now a million is the third value. What are the ranks of x now? So if you had to tell me like the lowest to the highest, what are the ranks? And you'll note it. This is where we got to notice a key concept also. What are the ranks of x right there? So the ranks are, you say the lowest one is 1, the highest one is the highest. Well, so those are the values. So the values will be kind of what they are on the number line. Well, so those are the actual values. Like that's the actual values. So imagine there's 10 people in a room and you're the tallest. What is your rank from lowest to highest? If there's 10 people in a room and you are the tallest, what is your rank? So if there's 10 people in a room and you are the tallest, what is your rank? Your rank number 10. So think about this vector right here. If it goes 1, 2, a million, 3, what are the ranks of this data set now? Like if you were to say the lowest, the whatevers, so the ranks of this would be what? What would the ranks of it be? Well, it goes 1 through 4, and good answers right there. It would be the ranks would be 1, 2, 4, 4, 3. Does that make sense? This is 4 because why is a million 4? A million is 4 because it's the whattest number. Hey, Jesse, good to see you. We're about to do some tool one after this. It's the highest. So does this change the ranks? Am I changing the ranks right now by changing this value? Have I changed the ranks of these? No. So what do you think Spearman also handles when we talk about regular correlation? We say QQ straight enough, no outliers. What do you think Spearman also fixes for us? What do you think Spearman also fixes? It deals with what's that we usually have problems with regular correlation. Because now it's still rank 4 no matter how big I make it. It's rank 4, it's rank 4, it's rank 4. It deals with outliers. So Spearman is the alternative to Pearson. Well, outliers on these great answers, everyone, and good job following along. This is the way to learn it conceptually, to be like, oh, it doesn't matter, as The Rock would say.
It doesn't matter.
If that value is a million or a billion or a trillion, it's still rank 4. So it's going to deal with outliers. It's going to deal with nonlinear relationships. And it also deals with what's called heteroskedasticity, which is differing spread. But here's the big thing where I really want us to go with this right now. I want us to make ggplot for Spearman correlation. And so a really great thing to do. Ooh. Looks like someone's got some code right here. I like stack core. That's good. That's a good plot. Are they going to show the Spearman on it? Well, this is a good plot. And they got the p-value? Ooh. Okay. That's got the code right there. That has the p-value of the correlation, but then did they... Oh, and they got method. Oh, and then I could change the line. Okay. I think I see how to do this. Okay. Add regression line. Can I add the los? Okay. So this code right here we just found allows us to make the following plot. I think I have all the packages closure, what it's mad about something. Is it this one? What is it? I copied your code exactly as it was. Oh, they made a data frame. Okay, they're storing it as data frame. Oh, we don't need the factor thing though, because they're doing multiple. We're not going to cover that yet. That's a different topic. There we go. Okay, now we should have it. Okay. Geom smooth. Okay, cool. Wow. I mean, this graphic right here. So Brian, we've got the graphic we need for this week, one of the graphics to show the correlation. But look here at the end. I'm starting to see some what here at the end of the plot. Do you see what I would see in this that maybe I would need to talk about? We can add titles to this, but I'm starting to see some what right here, especially towards the end. And I should be able to change this. I think I can find the code. And then we're going to do 201. I'm starting to see a bit of what, especially since all these points over here are above the line. This is going through the line, which is what we want to see. And then you've got above the line again. I'm starting to see elements of what? This is like bad right here. That's bad right there. Parabolic, nonlinearity. And so outliers would be like the further they are away, because it might be, imagine if we were to fit this right here, that fits through the data better. So I think it's going to be the add regression line right there. So we can actually go to the Spearman, because we should be able to just change this right here to, all their comments are so long. Custom regression line. Yes, we know what that does. And let's go here and say Spearman. Ah, I see it got a little bit better. Hey, Chase, good to see you here. And we got the Y labels. They put their labels in on the positions. And let's change add regression line to los. No way is that going to work. Oh, did it actually work? Oh my gosh. Okay, look at that. We've done it. So this is local regression right here, which is going to fit like a spline, a bendy line. And I don't know if there's a quick way to fit a, with the add, we might be able to add something like a parabolic. Let's look at the add really quick. Where's the add? There's probably a lot of things you can add that I don't know about, but add, and don't go over what add, everything you can do with add. So with this, hey, good to see you, Chase. So with this right here, if we want to talk about a Spearman relationship, it's better that we do the following. It's better that we do this. And I think my, let me go to SciPen. Options SciPen equals 7. And now let me remake this graphic. No, SciPen's still going. But does this make sense right here, Brian? This is what we're going for. Let me put the code or the website I found in the chat right here. But this right here, Brian, is a really great way to make these plots. Cool. Awesome. We get some points right here. Let's throw some more points in the chat. But these plots right here, understanding what you're seeing, that this is the value of correlation. Can we make it not say capital R? I like lowercase r. And then the p-values for them right there. You want your plots to look good. Hey, Sloan, we're talking about correlation right here. And it needs to be linear. And you need to not have outliers. And we're about to do some more 201. This is 320 talk on it. So this is this week's assignment. We'll need to also make the permutation output. I'll probably be sending that out and we'll do it during lab. But this was a good kind of walkthrough about different types of associations right here, linear, non-linear associations. And if we wanted to use our other data frame, it'd be really easy because we would just take survey 10 data frame right here. We would take the y variable equals this and the x variable equals this. And then we should be able to run it. And then we get our plot right there. This is where we're going to have to move this to 50, 200. So 200 on the x and 50 on the y. And that's much better there. So now we have it. And this is, so Brian, this is what we want to go for, is if you notice the graphic looks really good right here. And last but not least, I'm going to do two more things to this, and then we're going to do some 2-1. No, Megan, this is it. This is it. Correlation does not prove causation exactly. It doesn't prove if you weigh more, you will get taller. How do we know when to use the app or when to solve? Yeah, good question, Matt, right there. The questions will say use the empirical rule if you have to use the empirical rule. So it will say that right there. And we're going to do two last things to this. We're going to go plus GG title, and we're going to say correlation between height and weight. And then next, we're going to go right here and go to plus easy center title. And now the title is centered in right there. And we're going to store this. We're almost done with this graphic. This is something we really stress in 320 is making our reports look good. We talk about it in 201 also. And then last but not least, we're going to add to it GG theme. Theme. Let's go to theme. I think I like that one. Is that the same one I'm using? No. Theme economist. Economist. Wow, I can't speak today. So there's a lot of things you can do with this, a lot of ways you can change it. I would just move up the title right there on this to 55, and I think we're good then. That might do it. Sure, just find a spot where it's really good. And oh, and then we need to do the easy center title afterwards because it's changing it with the theme. There we go, and that's got it. So would you be proud of this plot right here? Would this be a good plot to display? Thoughts on it? That's what we're going for is in 320. We want great graphics that people can easily understand. Talk about the non-linearity of this relationship. Talk about the values of correlation that we find. Talk about the statistical significance of the correlation and, you know, what this means. So with this, have we done chapter 6 yet? All my notes are getting smushed together. Yep, we've done chapter 6 notes. That's last class. And this was kind of a review over it. So we're going to head over and do some 201. 2 seconds. Let's do it. You're welcome, Brian. Head over here. Okay, let's do some 201. There were a few questions at the start. You're welcome, Brian. So that's kind of a review of this week. That's most of the material. And people were saying the Canvas content, so I think we should do Canvas content. And let's go over here and do Canvas content. Canvas content 201. Is that what people want? 201, what would you like? Data Analytics 2 needs to get finished graded. I contacted the graders. Traffic engineer question. Which one's that on, Chase? Is that my Pearson? Is that my Pearson? Chapter 5 quiz part 2? I think we haven't done that one yet. We've done, someone mentioned the 80%. 5.2 with steers. Let's do a little 5.2. People mentioned the Canvas content, but we've done Canvas content last week a lot. I don't think we've done this tier one, but we're going to do those right here. And thank you so much, Megan and Chase. Sorry for the late start today, everybody. Had to do some appointments and stuff. Assignment manager. Let's go check it out. Body temperature from the quiz day. Yes. We might. I think we can do that here. Thanks for asking. Let me get the... So the body temperature... You can use the applet for that, but you should know how to solve it without. We got just enough. Let's do body temperature first, because you asked that earlier on. So let's do that one. All right, canvas content, body temperature. And these are the ones to know how to solve. Okay, so let's go check out the canvas content. Hair's going crazy. Notice that the recent one, number 2, hasn't been graded. They should be. One of the graders is a little behind. I've been reaching out to them, and so sorry about that. Like 70% are graded, so they should have it graded. But yeah, they should. Let's go check this out. We're looking for the 80th percentile question, which this one is not. So we're gonna have to regenerate this. Here, submit the quiz. Steers 2. We'll do the steers one here in a moment. 80th percentile. Okay. So with these problems come down to practice. Practice. I can't state it enough. Practice. So you have to know what you're looking at right here. Are you ready? Let's go ahead and take a screenshot of this and know how to solve this. So with this, the first thing you should do with any of these problems is what? If you're working on it on the test, the first thing you should do for any of these problems is what? This is, do it with me now to practice if you're watching. First thing you should do is what? There's 2 things which I would say I would do first. Right, boom, Megan, good answers right there. Mean and standard deviation. So mean is right here. That's mu. And standard deviation is right there. I'm going to put some arrows to them because I'm blocking them a little bit. So that is mu. And that is sigma. And then what are these? It says on a normal model with that and that. So what are those? It says the middle 60% on a normal model with a mean of 0 and standard deviation of 1. So what are those values? They represent what? So it's saying that this right here is that point, and this is this point. Hey, what's up, Andrew? We might have enough time, Nick. Yeah, we'll try to do that. So what is it saying? What does mean is 0 and standard deviation of 1 mean? Well, kind of. Well, so not quite to -1 and 1. It should be marked. Tell me if it's not marked, Jesse. They should always mark why they take off points. Tell me if the graders aren't doing that, because then I'll talk to the graders. It should always be clear why you lost points. The shaded part is 60%. The middle 60% has been shaded below. But what are the, like, what conceptually are these values? And there's a hint down here. These values conceptually right now are what's? Conceptually, on the standard normal curve, everything is a what? This is called the standard normal curve. Z-score. Yeah, those are all Z-scores. Perfect. So we have to know that they're showing us right now the Z-scores for those values. But we can mark a little bit more on this curve. How much are each of these areas worth over here? How much are each of these areas? Send me an email about it and let me know. Say I don't see comments, and then I'll figure it out, and then I'll talk to the graders and I'll say you need to. There should be a button clicked also. See the button clicked? They'll probably have clicked the button to make sure it says like a certain thing. So this question asks, where is the 80th percentile? So the 80th percentile means what? So if you think about body temperatures, the 80th percentile would represent what? As in, the 80th percentile is on the left side of the curve or the right side of the curve, and what does it mean if you're at the 80th percentile? So then we have to understand what the concept of 80th percentile means, because we've done a lot of marking on this. You won't use the app during the exam, so we won't actually need the app. We could use the app to solve this right here. So you could solve this with the app and probably get the right answer, but on the exam, you won't use the app. You'll have to understand the pictures. It's on the right side. So it means, well, so where is it at? Is the 80th percentile right here, right here, right here, right here, right here? Which letter is where the 80th percentile is at? Which letter is where the 80th percentile is at? Which letter represents where the 80th percentile is at? C, correct. Because the 80th percentile is where 80% is below that point. If you go right here, 20% is above it and 80% is below it. Does that make sense conceptually? 80% of the data is below that arrow. What do we know for the 80th percentile? For the 80th percentile, we know it's what? For the 80th percentile, we know it's what right now? What do we know for it? What does that value mean? That is the what for the 80th percentile. Well, not its standard. Well, kind of, Megan, kind of. I mean, it's related to that, but that's not the standard deviation for the 80th percentile. The point right here, this is the where the 80th percentile is at, and it is the 80th percentile because 80% of the data is below it. So that's why this is the 50th percentile, because half of the curve is below it. So the 80th percentile is where 80% of the data, if you were to put an arrow, the 80th percentile is where 80% of the data would be below this point, because 60 plus 20 is 80%. So what does this value right here represent? It's the what for the 80th percentile. That value right here represents the what for the 80th percentile because it's on a curve with a mean of 0 and standard deviation of 1. That is the what for the 80th percentile. The z-score, yeah. What does the z-score tell us? It tells us how many whats something is from the what, and in terms of negative or positive, above or below. So what does the z-score tell us? You're on the right track. This is the learning objectives. How many standard deviations above or below the mean, right? So think about this. We know that the answer is 0.842 standard deviations above the mean. So you can write it out right here and say, well, if I know the mean is 98.2, then I would go up 0.842 standard deviations, and a standard deviation is 0.7. And remember at the start, we marked our mean and standard deviation right here with these values. So we would know that the curve is normally distributed with a mean of 98.2 and a standard deviation of 0.7. We can also write these values on the curve right here to help ourselves out and put 98.2. That's a horrible 98. 98.2, 98.9. If you had to guesstimate the answer, what would you guess it to be? You can find the exact answer, but if you had to guess the answer, what would you guess the answer to be? So just if you took a guess at the answer, what would you guess it to be? 98.8. Guess what? If you guessed it, I think that would actually be good enough. So here's the math right here. And then you add that to 98.2 and you round that, and it's 98.8 rounded. Also, we could have done this one via the apps, but that's not really a good way to, because on the, I think I typed something wrong. 0.842 times 0.7 plus 98.2. There it is right there. I was like, what's wrong with that number? But once again, you will not use this on the test. So it wouldn't be a good idea here to go to 98.2 and then go right here to 0.7 and then go to the 80th percentile. And we want to go below. And there it is right there with a few more decimals calculated. And if you round to 1 decimal, you'd get this. So there's the 98.8 answer. And does the picture on this screen right here, does that look a lot like the drawing over there? The spots just, oh, we could have done this. You watch this. We could go here to between and do 60. And then it tells you the two numbers. And then our drawing looks a lot like the other drawing right here. And you can see where the 98.8 would be. And there is the graphic. So we could find the exact answer, 98.8. That's the upper number right there, and make the drawing look the same with the middle 60% shaded. So that is how to do it. And you could also get the z-scores if you wanted by going back here and doing a mean of 0 and standard deviation of 1. And then the z-scores we supplied to you are right there with 0.842. And that's what you're given to solve the question. Does that make sense? How are people doing on this one? Understanding it's the key, though, to understanding what z-scores are, how to use z-scores, what the 80th percentile means. If you understand these types of questions and can solve them, try writing your own to be like, where would the 20th percentile be? Well, the 20th percentile would just be that many standard deviations below. So I could solve it here mathematically and do 0.7 times 0.842, and then go to 98.2 and subtract it. And there's the answer right there. So you could then check your work. And if we go back here, there's the same answer on the screen, if you notice. So whoops. Oh, standard deviation of 0.7. So you want to be able to solve similar problems. And you see I have 97.6, and that's where the 20th percentile would be. So you could also just put in 20th percentile and do below and get the same answer. I have to move rooms will be extra early. Yeah, awesome. Yeah, that's the whole point. Thank you, Megan. I don't want to just solve the answers. I want you to see how it works and then how you could solve questions that are similar, like where is the 20th percentile? And the reason we can solve for the 20th percentile is because the 20th percentile is where 20% is below that point. So the 20th percentile has a z-score of negative 0.842, and it's symmetric, or the distance it's away from the mean is the same as the distance of the 80th percentile. They have the same amount above or below. So really good questions. Let's do some Pearson. Okay, it's time for some Ma Pearson. Ma Pearson time. Thanks to everybody who showed up today. We got a bunch of people watching. I have 8? Can we do chapter 2, part 2 quiz? You're talking about chapter 5, right? We're going to do some of those right here, you bet, Matt. We're going to do, I think people said the steer question, and then another one. I'm trying to think, there was like the steer question and a few others. So let me know your questions. We've got just a little more time right here. Summon manager. Drop those questions. Remember, every time, number 5? Which ones do you want to do? Every time you do it, the questions are different. So you have to tell me which question. Oh, there's not that many. Okay, you pretty much have to use the apps for all these, but data analytics number 4, we have a video on that. Let me send you the link and let me start posting that. Data analytics 4 we did last week. That one takes a little bit more time to do. So let me go find that real quick before we get started here on this. I'm going to find data analytics 4, and I think it was 15th or 14th we did it. Data analytics 4. Here we go. Found it. I'll send you the link right here. It was Wacky Wednesdays we did it. Okay. Here we go. Oh, did Sloan already found it? Oh my gosh. This is the link. Sloan's got a pin right there. Thank you so much, Cam, who donates to elementary school. Yes. Here we'll do the steer question first, because I know people mentioned that. Can we do the Corey has? Yeah. Although homework, we might do as much as we can on the quiz right now. Did we do the homework during class? We didn't have full homework, did we? We could try to get that one in. We'll try. We will try right here. Disappear. Steer weights. Where's steer weights? I'm in the async. Yeah, let's do it, Nick. You bet, Nick. Let's do that. Let's get that one. We'll do that one for you here. We'll do that after this. Here, we're going to do steer weights first. Let's go do steer weights. Thank you, Nick, so much. And we appreciate everyone being here from all different sections, all different classes. So we're here to help out. Let's do the steer weights, then let's do that one, Nick. You got it. Stat 201. And this is chapter 5 quiz. Now, if you're watching this, a lot of these problems right here, we can kind of solve by hand. I'm going to take guesses at all these, and then I'll tell you how I made these guesses. These are just guesses to start. So all of these are just guesses, only guesses. So trying to think, the 10th percentile. Is the 10th percentile above or below the mean? Just say above or below in the chat. Don't look at my answer here. No, is the 10th percentile above or below the mean? Is the 10th percentile above or below the mean? Is the 10th percent? Oh, the highest 10%. Ooh, that's the highest 10%. That's the 90th percentile. So I misread the question. The highest 10%. And so it says highest. Sloan, 100 points. You are correct. And Angie, you are correct also. Sloan corrected me, though. That is the 90th percentile. So be careful. Made an error right there. We just actually looked at the z-score for this one right here. It's 0.8 negative point. You know what I can do then? I can cheat. Watch this. So since we know the z-score for that, we just looked it up. We can actually use it to solve this question. So you could actually solve this question by taking the z-score. So 0.842. And I'm going to show how we actually would solve these for this here in a second. But review the question we just did if you want to see how I'm able to do this, because I have that z-score in my head from just solving it, and it says round to 1 decimal. We will get that one correct because we just cheated right there. Middle 40% is really crazy hard to find, at least without the applet. So we're just going to take random guesses right here. We might only have one correct, but we'll just go with these guesses, and then we'll see how we do. We should have at least one correct, and we did only get the one correct. Okay, so let's do this. What do you look up the z-score on? Great question. So to look up the z-score, the best app we have, the number one app we have right there, Sloan already knows it, is the Adam Spanbauer apps. So we're actually not going to use the z-scores. We're actually going to straight up solve it. So what we can do, 2 seconds right here, as we put them side by side on the screen. Side by side view. Here we go. Let's reduce the size of this. Now this might get a little small. Here we go right here. So we're going to take the mean of 1,156 and put it right here, 1156. Now it has the mean of that on the curve. Next, we're going to put in the standard deviation of 87, and then practice knowing how to solve these, because you can solve it interesting ways right here. It says the highest 10%. So the highest 10% is the what percentile. Here's what it looks like visually, but the highest 10% is the what percentile. The highest 10% is the what percentile. The highest 10% is the what percentile. Oh, was our guess 170? Holy mackerel, I was close. Not close enough, though. The highest 10% is the what percentile. These are concepts we should know pretty quickly. The 90th, yeah, that's right. Because think about it. If it's the highest 10%, then 10% is above it, and 90% is below it. Those are concepts we need to know, and we should be able to see right here. Like the highest 10% is the 90th percentile because 10% is above it, 90% is below it. The lowest 20%, this is what we just did earlier, where we saw something like this right here with the between. So I was able to find that answer. This is a question we just had on it, but we would supply you the pictures, and I used the z-scores to solve this. So if you want the lowest 20%, the best picture is going to be to go below 20% and enter in the mean and standard deviation first and do the bottom 20%. And there's the answer right there. And you can even round to 1 decimal. Hey, Megan, good to see her. So you can round, and we could put in the more exact right there because it's going to carry all the decimals for us here. So what do you think I'm going to click over here to get the middle 40%? What do you think I'm going to click over here to get the middle 40%? What do you think I'm going to click to get the middle 40%? What do you think I'm going to click over here to get the middle 40? And you want to be on X from p-value because you're entering the probabilities. Between, so we can click between and go to 40. And then it gives us the values right here. And we've got it rounded. I wish it rounded down here to 1 decimal also. We can take this right here. What? Look how close I was on that. That was good guess. Shocked I got that close of a guess. And then, wow, I was really close on those guesses. I've done these too many times. But you could have also done outside of and done 60%, because the outside 60 would leave 40% on the answer. Yeah, it's so makes solving these so easy, because now you just go to check answers and you got 100 on it. But the thing is knowing what the app is showing you. Also, you could have solved these using z-scores. So knowing how, if it gave you the z-scores right here, negative 0.52, you could take that z-score of negative 0.52 times the standard deviation of 87, subtract that from this, and now you would get this value right here, which should still be acceptable. It should still accept that, we would hope. Yep, it does accept it. So I can use the z-scores, since I know how to use z-scores to find answers. I wouldn't round it to 1 decimal place. You can use the z-scores to find answers. If you want extra practice, try using the z-scores instead. It makes the problems a little more difficult, but goes to an additional understanding of how, if the z-score for this is 0.524, then I could take the standard deviation, times it by 0.524. So standard deviation right there, because that's how many standard deviations we are above the mean, and then add it. Can you do the other steer problem? Yeah, let's do the other one real quick too. And then we're going to do Nick's problem right here, and there's the answer. And that actually does round to exactly that. I think the other steer problem, where is it at? Might be right after this. That's IQs. They're very similar. Where's the other steer one? Then we're going to do Nick's question next. Normal model. Here's steer weights. Okay. So this one is very similar. It's asking the 51st percentile. Now, whenever we see percentiles, it means area 1 on the curve. Whenever we see percentiles, it means area what to this point. Whenever you see percentiles, you need to think it's area what to this point. Whenever you see percentiles, you have to think it's area what to these points. Whenever you hear about percentiles, you have to think it's area what to these points. Below this point. That's what a percentile means. So you'd want to be in the higher percentiles. So the easiest way to do these is to click below right here and then enter in the percentile. Make sure you're on the X from a p-value, which is the percent we are shading in. And there's the answer to the first one. It says round to the nearest whole number. So guess what we're going to do? We're going to go here to rounding. And now it's just going to straight tell us the answer right there. Even rounded perfectly. Thank you to Adam Spanbauer for putting the rounding. The 94th percentile right here. If you notice, this is going to be further over on the right on the curve. It's already rounded for us nice and perfect because we rounded to 0 decimals. And then the IQR. What does the IQR represent? What does the IQR represent? So the IQR stands for the interquartile range. So it's one value technically, calculated from two values. But what does it mean and how can we find it? The middle, so maybe we click between and put 50. And then right here, we take these two numbers and we what them? So I'm going to take these two numbers right here and do that. There we go. So how would we do this? Good question. How would you do this on the exam without the applet? How would you do this on the exam? So this one right here, we didn't use the applet for. You're right, Megan. The distance between Q3 and Q1. Exactly. And Sloan's got it right there mathematically. Great notes. How would you do it on the exam without the applet? We will give you pictures. Does that make sense? So every one of these could be found. If we did this sort of question on the exam, we could simply give you something like this right here. And we could ask you what the IQR is. And we could give you the following information. So I'm going to change this right here. Or I'll just take this picture right here. So it could read, here's a really quick exam version. You ready? Test scores were normally distributed on the exam with a mean of 80 and standard deviation of 10. What was the IQR using the data below? Or what was the IQR? What was the IQR for the exam? Okay. Take a moment. And if you know how to solve these questions, you can get them pretty quickly. Who can get this? Yeah, expect some crisp. Yeah, boom. You know right there, Mason. See if you can solve this. Okay, I think I got an answer. I can round it to the... round to the nearest whole number. I can do that. Read, that's 100 points. Yeah, that's exactly it. Yeah. So you can technically take the distance these are away and then do that many standard deviations, which is quicker, was what I was doing in my head. But you could also go right here and get the lower 25%. And here we'll do it. Read, great work. I gotta throw you another 100 points, Read. That was, yeah, exactly how you would solve it. So you figured it out. You go here to 80 minus the z-score, which is 0.67 times 10, and then 80 plus 0.67 times 10, and that is going to be equal to 73.3. This is equal to 86.7. And that's the 25th percentile, and that's the 75th percentile. We're going to nick your questions right next. And then you would subtract those numbers. 86.7 minus 73.7. There we go. Exactly. So, Reed, that's how you would solve these types of questions where we could give you z-scores. So if you understand that kind of work right there, you are way on track for these problems. That's maybe I'd put that at a challenging question. So if you got that, we would just show you a picture like this, and then you'd have to solve using the information. But But for the homework quiz, did you recommend? I do if you want to learn it the best, use the app and then do it by hand. So like doing both is going to be the best. But if you really understand how to use the app, we're just showing you a picture and then you should be able to like figure out how to, yeah. But if you really want to super learn it, do it both ways. Like make a picture and then solve it using Z-scores and then check your work. Can we go over the traffic engineer? I think we'll do that next right here. Chase, you got it. Traffic engineer. And then which one is yours again, Nick? And thank you, Reed. Really good question right there. Got the test coming up next week. Traffic engineer. Which one was Nick's question? Was a homework? Oh, it's the playlist. So let's go find that. The playlist. Okay. The playlist question. Chapter 5 homework playlist. Was it like normally distributed stuff? The Corey one? Here we go. Let's go take a look at this. Corey has. Okay. Oh yeah, let's check this out. Colin, good to see you here. Happy time from Disney. Companies, we might have enough time. Yeah, SI, Alyssa's having a great study night. Shout out to Alyssa right there. So we got a lot of cool stuff right here. We've been doing a lot of work on this in 320. So I might even pull up some of that here to show it. What we have right here is the lengths of songs have a mean of this. There's the mean, a standard deviation of this. So they're talking about, now they gave what is called a normal probability plot. Ooh. How do you know if data is normal? Well, we have 3 ways. Way number 1 to know if data is normal is to look at it. Don't look at that though. So these are the 3 ways to know if data is normal. This is a good review here for anyone watching this question. So if you have data, let's make some data. We'll call this data 1. Don't worry about coding. We're just talking about how to make data. Does this data look normal? Yes or no? Does this data look normal? Yes or no? Good job, Matt. Does that data look normal? This is way number 1 is look at it. Yes, it's unimodal symmetric. Now, way number 2 is what's called a normal probability plot. Now, a normal probability plot shows you what you see in your data versus what you would expect if it's normal. So the red line is where the numbers match up. Like you see how -2 matches -2, -1 matches -1, 0 matches 0. So the red line is where those numbers match. So if your data's normal, it'll do whatter. It'll do what more often? Like -3, we observe around -3, and these are z-scores. We would expect if normal around -3. So if your data, the black points right here, is normal, then you will see this plot do what? It'll follow that line. And you could say it has a, we don't say that, and so Jesse, really good answer right there. It'll follow the line, but we don't really say too much. Well, not quite like a relationship. This is not quite chapter 6, Sloan. Good answer, Sloan. We would say that it follows what we would expect for the normal. So the values down here on the bottom are what we expect if normal, and here's what we observe, and our data is very close to what we would expect. Does that make sense? We were doing this last week, and I'm going to show, I made a really good graphic. I'm going to go grab it really quick because I'm just really proud of myself. Yay, Brian. Where's my really good graphic? And then I'll do the last way, and then we'll answer this question, which is the big part, is understanding the concepts behind this. So this was a graphic I made to communicate the results. So I did it for 3 different graphics or 3 different plots. So there is my graphic right here. You've got 3 different distributions. And for the most part, what would you say? I mean, a little bit of weirdness over here in this one. These are 3 different distributions. But for the most part, they mostly all do what? So you see, this is theoretically what it should be. And then this is what we observe over here. So this is the observed. And then this is the expected. I would say, for the most part, all 3 of these distributions mostly follow the normal. Does that make sense? For the most part, all 3 of these mostly follow. Like, there's weirdness right here, like, boo. Not good. We don't like that. But for the most part, they're all good. Let's look at ours. How's ours doing? There's the line. There's our data. Here's what we expect. Here's what we see. They didn't z-score everything. Still follows the same thing with the line. How's this one doing? This is as clear can be. So remember mine were like, hey, pretty good. Crazy. So this does not follow what we would expect. So we would say right here, is it normally distributed? No, because it does not follow the diagonal line. Excellent, right there. If it isn't normal, how does it differ from being normal? Now, this is a tougher question right here. This one is, you'll see the answer right here. It's a little tougher to answer. So this data we said is normal, right? And this data looks like this. It follows the line. But let's make a data 2 right here. Now with data 2 I'm taking from an exponential distribution. Let's see how this data looks. Data 2 is very, very what? It's very clear. Yeah, it's Sloan, you're seeing it. Data 2 is very, very what? Data 2 is very, very what? Extremely this. Skewed to the right. Monster Man coming in here once again. Right to the high, left to the low, whatever way the Monster Man's tail goes. So you can see him right here, and that's the shape of this distribution. We got Monster Man. We always have to acknowledge Monster Man right there. Right skewed distribution. So when you look at a normal probability plot, done here with the QQ plot, what you'll see is, and this looks very much like the one we just had a moment ago. So if you look at this plot right here, I can't keep it open, but they'll both look very similar right there to what we have. I mean, that looks a lot like ours. And this is the plot of the data you just saw a second ago as a normal probability plot. The way I like to remember which way these are skewed, there is a more technical way by saying that our observed values, like right up here, is a lot higher than what we would expect. Higher values than what you would expect leads to right skew. Or you can do my little alien man trick right here. So you got a little like Squidward-like creature right here, and he's just over here, and he's just blowing it to the right. So that is right skew. Now, if you had left skew data, it would just blow to the left, and that's just kind of the trick I use to remember it. We don't go that detailed on the test, but this is left skew data right here, and it'd be below to the left. What does the red line mean? It's where we perfectly see the normal matching. Good answer, Sloan, right there. It's where we perfectly match. If that's the link for the clash. Oh, here, Sloan, I'm going to remove that. Here, wait, Sloan, I'm going to do this. Here, wait, Sloan, if you could remove that message, I'll tell you why here real quick. If you could hit remove on the message real quick. Thank you so much. Since the classes are on unlisted videos and this is a public stream, that way we don't have, randos joining the class. No worries, Sloan. Someone who had been here to get it. Could you please go over chapter 5 NFL? We might have enough time. So thank you, Sloan, right there. 100 points. You're a huge help, Sloan. I haven't sent out the link for today yet, but they are always posted under Watch Class Live. So does that make sense right there, Nick? You can tell if it's normal, if it follows the red line, which is what we would expect given the normal. This one is right skewed because it's pushed to the right. We don't go that detailed on the test on relation to skewness, but a pretty good question, especially on the first part of it. First part is A+ on knowing that if it's normal, it should follow the theoretical normal. What was the next one we had? We'll be able to do at least 2 more, I think, and then we're going to jump right into class, basically. Traffic engineer. Let's head over here. We got traffic engineer. And we've got NFL and traffic engineer. And we did one similar, Maddie, to the IQ test. Check out the steer questions because they're very much the same concepts, just with different data. So the big thing is we're just using different data, and knowing how just using different data, you get basically the same stuff. So we need to find the traffic engineer question. Let's go find chapter 5, part 2 quiz. Traffic engineer. Or what's the next one we have on the list? Thank you so much, everyone. Sorry for the late start today. Traffic engineer, we're going to try to find you real quick. How's everyone doing today? Everyone have a good weekend? I'm not from US, but Canada. Oh, Amon. Thank you, Almond. That's nice to hear. I appreciate that. I hope these videos have helped you out with whatever class you're taking. Well, that really brightens my day, Almond. What videos have helped you? What have you used? What classes are you, if you want to share what you've used or what classes you're taking, that helps me build content. I appreciate it. We sometimes have random people stumble across the videos here and they get help. I've gotten emailed from people at different universities, and we're about to do a traffic engineer question on the normal model. Let's get ready. Well, we appreciate all the positivity here. That's what we're all about. We're gonna make. Yeah, yeah. Well, let us know if you have questions. And there's a bunch of playlists with review videos. So if you want like the speedrun playlists, so here we go. I'm just gonna mention this really quickly right here to Amin. And thank you, Amin, so much. If you go over here, Amin, your best videos for you are probably gonna be if you go over here to the playlists and go here to playlists, and if you go to like the speed runs or the chapter reviews, those are probably going to be your best videos. You just need to search and go to all chapter review. I'll drop this link for you here real quick. This is pretty good, like no joke playlist right there. So Amin, I hope that helps you out right there. You can look to see what's covered in the chapters. But then also a really fun playlist is the speedrun playlist. Those videos are a little more fun, I would say. There's test 3 speedruns and test 1 speedruns right here. You're probably on earlier material. So here's the playlist here too, Amin, on that. Awesome. Finally finished 2 weeks worth of work. Nice job, Megan, right there. Amin, feel free to come by anytime, ask questions, ask about review. You might be covering the same exact material as us, so we'll review with you. Thank you. Appreciate that. Okay. Here we go with the traffic engineer question. Let me mark through here. Oh, you like the speedruns? Yeah, those are fun to make. Yeah, we'll try to do the IQ one right after this. You got it, Matt. Here we go. Speedruns were the fun ones to make. Okay. We got traffic engineer. We might have to speed run the question 2 after this. 10203 stat 201 chapter 5 quiz part 2. Okay, and I'll send out the announcement to class. Okay. A traffic engineer records the speeds of cars going past their home where the speed limit reads 20 miles per hour. The mean of the sample size of 100 readings is that, and the standard deviation was this. Click to see the summary statistics for the speed of cars. Ooh, so they're giving the quantiles right here. So there's the 5-number summary with additional information. There's more of a pull here on the high side, what I'm seeing. Are they going to go into symmetry? This one looks complex. Ooh. That'd be awesome. But, I hope you're all right, Megan. So it says, using a normal model, what values should border the middle 95% of cars? So what we're going to do right here is we are going to go to the apps. So it should be the answer from the apps, but basically 2 standard deviations. So once again, we talked about using the app a lot today right here. It's in the chat. I'm going to pin it here in a second. So this is going to be the new pinned message. So replace the pinned message right here. And here we are. So now we need to put in the mean and standard deviation. 2 seconds as I get my screen situated. There we go right there. And here we are. So the mean was 23.84. The standard deviation is 3.56. And the middle 95% between these values, round to 2 decimals. There's the answers. That is the middle 95% on a curve with a mean of this and a standard deviation of this. As long as we copy down the answers correctly, ascending means going from lower to higher. And now it's going to ask about the actual values we see. So these are the theoretical values. And then it wants to know the values we actually see. So the middle 95% would mean we'd pick what 2 numbers on here. So if we're at the middle 95%, which percentiles should we pick for the middle 95%? So go ahead and answer that. And I'm going to email the class real quick and say, class in 10 minutes. So what percentiles would we pick right there? What percentiles would we pick? Who knows? Someone might have said it already. Going to watch class live. About to send out the link right here. Class in 10 minutes. Go announcements. Plus class in 10 minutes. See you soon. And click here. So the middle 95% would be between... Oh, no one said it. No. It'd be between here and here. And you could find that out also by subtracting the numbers. So if you go right here, good to see you, Seth, and do 97.5 minus 2.5, well, that's the middle 95% because 2.5 would be out on either side. So 30.8, Mason, good to see you here. Sent the right video link, right? So what was it, 30.63? So does it say to type? Okay, 30.63. That's the 97.5th percentile. Oh, we definitely do. I just sent the link out. Always class today. 17.03 is the lower one, and those numbers are pretty close. So if you notice, those are pretty close to what we should theoretically see. They're off by just a little bit, which are close to, they're not very different. Since the distribution is approximately normal, we should not be surprised. That should be it. I think I've done everything correctly. If I didn't, oh, we did. Good. We carried all the decimals, and it looks to be mostly symmetric, and they're just telling from the percentiles. I don't know it's normal. I wish they had just shown us the data too. I'd prefer to actually see the data right there. Here we'll do the IQ question to end. For the IQ question, these are the cutoffs of steers. We did a lot of steer cutoff ones. For the IQ question. Okay. So once again, what you want to do for these questions is you want to practice doing them with and without the applet. So you want to practice doing these questions with and without the applet. 106.43, Stat 201, Chapter 5. Do IQ questions. Okay. You're welcome, Jace, right there. Glad it makes sense. So these questions right here, what percent would we expect to be over 80? That's going to be about 81%, just taking a guess. What percent would we expect to be below 90? That's going to be about 25%. And between this and this, that's going to be about 10%. We just took guesses. So we got nothing right. So to solve these actual questions right here, we need to go to the applet question. The traffic question, did we do that one? I don't think we did yet. We might have to do it tomorrow because we're running out of time right here. So with this right here, we have to go over to the applet and put in the values. So once again, we put in the values right here, a mean of 100 and a standard deviation of 16. And we're actually going to switch to finding the p-value from x. So when we go to over 80, we'd want to go to above and go to above 80. And then it says to round this, well, it's going to be rounded to 1 decimal. So we need to increase the decimals. It's 89.4. Not a great guess right there. Not horrible, but not great. And it does show you the picture of it. And you can see that is above 80. And we want to do over 80. So that is the right picture right there. Next, we need to do under 90. So we go to 90 and we go below 90, 26.6. Much better guess, still not good enough to get it via guessing. And then between is going to be the between right here. And once again, know what the applet is showing you, that if you go to between and go to 120 to 128, it says 6.6 and it graphs it. If I had a little more time, I would do these and actually write out each one. Maybe I can do the traffic engineer one really quick right here. Needed, and I'm gonna have to do this really quick right here, Sydney, or I don't think we have enough time because I got to end the video so the next class can start. But swing by next office hours. We have until tomorrow, I think, to do the assignment. I'm gonna be adding an extra day to it. Until then, bye for now, everyone. Bye.